Good morning, this is Dr. Turner for Integrated Math 1. Today we're going to be covering section 4.5, which is looking at systems of inequalities. This is combining two topics that we've covered in previous sections. The first few sections of Unit 4 we're looking at systems of equations. We've talked about how you solve linear inequalities and how that's different from an equation. So we're putting those two things together in this section. Because we're doing online, we're only focusing on the basics. We're not doing any applied problems. If we have time towards the end of the semester, we'll be focusing on that. But for now, we just want to look at the basics. Because we're going to be looking at graphs, obviously, for equations and inequalities, one of the ways that we can do this is using Desmos. Now, the nice thing about doing it online is that if we have two systems of equations, let's say 2x plus 3y is greater than 6, and 3x minus y less than or equal to 2, for instance, Desmos is going to do this for us. So it makes it nice and easy. Of course, we want to zoom in and out. Now, here's the thing with systems of inequalities. With systems of equations, we said you could have two solutions, or you could have one solution, you could have no solutions, or you can have an infinite number of solutions. With systems of inequalities, we're either going to have an infinite number of solutions or no solutions. Now, Desmos will by default graph both of these, and remember, and if you need to refer back to Unit 3, I would do that. But anytime you have a greater than or equal to sign, we are shading above. If you have a less than or equal to sign, as in here, shading below once you rework the equation, right? Get y by itself. Now, in this example, for instance, here, because I'm just typing it in standard form, Desmos is doing it for me. But if I were to rework that by subtracting the 3x on both sides and then dividing by a -1, I'd be left with y is greater than or equal to a positive 3x minus 2. So this is the same inequality, it's just been reworked a little bit. So be careful with that. What you're going to be asked to do in this section, and for most problems involving systems of inequalities, is you're going to be asked to give an example of a point that is a solution and give an example of a point that is not a solution. When we are looking at systems of inequalities, and I'm going to change this here to be greater than or equal to, make that line solid here for just a second. What we're looking for is where the shading overlaps. Now, if we were doing this in person, you might shade one with a blue crayon, shade the other with a yellow crayon, and your solutions are where the two types of shading overlap. So looking at inequality number 1, these are all the solutions for that inequality. If I look at inequality number 2, those are all the solutions for that inequality. If I'm looking at a system of inequalities, I'm looking for any points where the shading overlaps, or any point that is on a solid borderline. So you'll be asked to give an example of a point that is a solution and an example of a point that is not a solution. And there are an infinite number here. So for instance, I could pick, let's say 0, 3. Okay. That's where that's in the area where the shading overlaps, therefore that's a solution. Okay, so now I would label it as such. If I pick a point that's not in that top section, whether it's over here on the left, whether it's over there on the right, or whether it's at the bottom, okay, all of those are not solutions because they're not where I have my shading overlapping. Okay. So 0, 3 is a solution. These other points are not. You might be asked to give more than one point as a solution. So, the easiest points I think are just going along the axes when applicable. So 0, 3, 0, 4, 0, 5, and you could keep going up. You don't have to pick the points on the axes, but they're the low-hanging fruit. They're the easy ones to get. Okay. That's most of your questions for your assignment, and that's what it looks like in a textbook as well. In addition to this, you might be thrown a curveball, let's say on the CASP test, where, and I'm going to delete all these points here for a second. Maybe I give you a point that's 0, 2, and you have to remember, is that a solution or not? It's not just where the shading overlaps, it can also be on a solid borderline. So it is meeting the requirement of the first inequality, that's on a solid line, and it's in the shading of the second inequality. Therefore, yes, that is a solution. But be careful, that only applies when the borderline is solid. So if I were to change this to, let's say, just greater than 6, now it's no longer a solution. It has to, if it's going to be on a borderline, it has to be a solid borderline. Let's look at another example. Get rid of these. And if you would like, if you're doing this on paper, if you want to rewrite it in slope-intercept form, that's good. Y is greater than 1/2 x minus 3, and y is less than or equal to negative 2x. Okay. So one inequality I'm shading above, one inequality I'm shading below. Again, my solutions here are where the two shadings overlap, so above that line and below that line is my big section here on the left. Give me an example of a point that's a solution and a point that's not a solution. Again, the low-hanging fruit anywhere on the axes. So let's say I pick negative 2, 0. That's in the double shaded area. Point that's not a solution, anywhere other than that left section. So again, low-hanging fruit, it could be 2, 0. That's only one type of shading, so that doesn't count. I could do 4, negative 4, put it down there in the bottom. That's not a solution. Or it could be straight down, 0, negative 6. That's not a solution. So it has to be where you have both types of shading. So any point in there. Again, I could throw you a curve. I could ask you specifically if a point is a solution or not. So for instance, 0, 0. It's on a borderline, but it's a solid borderline, so that point is good. So yes, that would be a solution. As opposed to, let's say, 0, negative 3. That's on a borderline, but it's on a dotted borderline, therefore it's not a solution. So most of the time, that's what your problems are going to look like. The only time where you end up with a system of inequalities where you don't have a solution is where you have two parallel lines that are shading in opposite directions. So for instance, let's say y is greater than 2x plus 1, and y is less than 2x minus 1. Okay. So on the first line, I'm shading above. On the second line, I'm shading below. There's nowhere where that shading overlaps. Therefore, I have no solutions here. Just because the lines are parallel doesn't necessarily mean you have no solutions. You need to pay attention to where your shading's going. So for instance, if I flip this to be also greater than, well, now I do have a section that overlaps. Here I'm shading above. Here I'm shading above. So anywhere in this left section, the darker section, any of those points are solutions. Okay. If I change this to be less than, I have a section where the shading is overlapping. So be careful with that. Just because the lines are parallel doesn't necessarily mean you have no solutions. It's when you have two lines that are parallel and there's no overlapping for the shading. Well, this was a quick section, but hopefully it makes sense. That's all you have to do for this assignment. If you guys need help, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.